Hello again, this is Tim Lloyd. This is another video from our advanced question set from Mr. Sandeep Gupta. Today's question, as I said, is a GMAT question of advanced nature. I wouldn't put it above 700, but certainly as soon as you're dealing in GMAT with questions that involve volumes of, for example, in this case, cylinders and cones, and then having further steps brought into the question, you can guarantee it's certainly a relatively high scoring and high difficulty level question. So let's get into this one. As you see, we've got various information in the question, and what we're going to need to do is break the question down into three parts. So we'll start off just by analyzing the initial information for the initial shape with the initial volume. This one is the volume of the cylinder. Okay, you can imagine almost as an oil tank. Now we always recommend 99% of the time, if you've got time, draw geometry questions, make a sketch, get the information put down on paper, get your variables sorted out, and of course write down the necessary equation. So here let's start with the volume of this cylinder. Okay, so no doubt about it, it's going to be, as I said, something like a fuel tank type of object, even if it doesn't actually look dimensionally as perhaps it should do according to the information. Try to make it look realistic. So here we are, we know the height and the radius are the same. Okay, so here the next step is to write down the formula for the volume of a cylinder. And this type of information is why you can consider it way above average and definitely a high scoring question, because volumes of solids, this type of information is expected not in average questions. Yeah, sure, if it were a circle, pi r squared, etc., but this is definitely considered a higher level formula. So the volume of a cylinder is pi r squared h, where h is the height of the cylinder and r is the radius of both ends, because it's a regular cylinder. Here we know that the radius is 10, so it's 1000 pi. Just double check that if you're not sure. That was the first part. The next part is to consider both scenarios. Remember, each scenario must satisfy twice the volume of the original shape, so in other words 2000 pi. With a cone, basically just think of an ice cream cone or something like that. I tend to draw this one always with the base at the bottom, and that may not make sense in this particular case, but it doesn't matter as long as we get the information down in the right place. So for scenario 1, the radius at the base is 10 and the height to the point is h. Now I'm actually going to call this h1, and the final part of this question will be subtracting the radius from scenario 2 from the height from scenario 1. So stage 1 is complete. Let's look at scenario 1 in terms of the volume formula for the cone. Okay, and it's very simple. It's pi r squared h divided by 3. Okay, where r, as we know in this case, is 10 and the h is the variable that we're interested in. Now, as we work through this, just remember, double check every step. We don't have a calculator. Sometimes it's quite easy to make silly errors when we're dealing with squares and other areas, other aspects, shall we say, of solid forms. And in a more difficult question, we can perhaps be considering the answer choices as a guide to help save time with calculation, but we'll go on to that in other videos. Now here we know that the radius is 10, so it's 100 pi h over 3. That equals the original volume of the cylinder, which is 2000 pi, so we can cancel out on both sides of this equation. Pi's cancel, 100 cancels, so we have 20 equals h over 3. You get pretty good at mental math the more practice you do, of course, and you're going to be doing a lot of practice as you move towards your GMAT. So once you've established that the height for scenario 1 is 60, maybe just double check your variables h1 And let's now look at scenario 2. Scenario 2, again, we're dealing with the original volume of 2000 pi, but this time we've got a slightly different setup. This time the height will be 10, so we're going to draw the upside down ice cream cone and put in the information, the radius this time of the base being R2, which we know is going to be the second variable, and the height, H2 if you want, is 10. Again, we just carefully write down the formula to make sure we don't make any silly mistakes. The original volume was of course 2000 pi, and we're going to use the formula pi r squared h over 3. Now, we generally consider geometry to be one of the easier topics on your GMAT. Yeah, okay, you don't have a calculator, but as long as you have memorized 20, 30, 40 pieces of information, flashcards, this type, whatever it takes, there are plenty of applications for mobile devices that include formulas such as pi r squared h over 3. It's absolutely essential that you are comfortable with the process of applying the information, and in this case, as you can see, all I'm doing is again cancelling both sides once I've put the information from the diagram, from the question, into the equation, and the pi's cancel, 10 cancel from both sides, and we get r squared is 600. So just make sure you're okay with that. Now, as I've said on previous videos in this particular playlist on our GMAT YouTube channel, we assume that you are already scoring regularly above 600 before you try these questions. The reason being, for example, the next step here, I'm going to deal with the inside of the square root. We generally in GMAT world, if there's a square root in the calculation, we don't end up with decimal answer choices. GMAT prefers to keep some form of square root, cube root in the answer choice. So what you do, you look for, just to make sure you're okay with that final step there, you look for squares contained within the number under the square root, and 600 contains 100. So with practice, your brain tells you these relatively quickly. That means you can separate the square root of 600 into the square root of 100 times the square root of 6. 6 times 100 is 600. You then answer what is the square root of 100? It's 10, and this is where we get the square root of 10 times 6. Now, this is an approximation question, so the next step is to try to approximate what square root of 6 is. And the way we do this, we say, well, the 2 squared is 4 and 3 squared is 9. Therefore, the square root of 6 is going to be somewhere between 2 and 3. Okay, this is a nice trick, and we'll do other videos which really focus on that. But if you're not sure, just do it on your calculator to double check. That means we're multiplying 10 by approximately 2.5, so the answer is approximately 25. Therefore, from scenario 2, we have the variable for R2 of 25. And the final step of this question, and this is why it's a higher scoring question, is because there are so many steps, is very simply to go back and say, well, the question asks us for the difference in the height from the first scenario and the radius in the second scenario. So in other words, h1 minus h2, and it's an approximation question, so it's 60 minus 25, the 25 being approximate, so the answer is approximately 35. There you go. That last part, of course, be careful not to make any silly mistakes. Look at all the answer choices, choose D, and move on. Thank you very much. I hope that was useful. It really is our passion to put out these free videos from question sources from Sandeep Gupta, as well as our own questions, of course, on other playlists in our YouTube channel. You can follow us on Facebook, you can subscribe to this YouTube channel, you can find us on various social media, and the key thing is, if you have any suggestions, if you have any feedback, any questions, and if we can actually help you, drop us a line. We'll be more than happy to get back to you. Thank you again. This is Tim Lloyd from GMAT.cz in Prague. We're part of Gain Access. See you soon in the next video. Goodbye.